Okay, so we are going to look at the concept forces in motion practice problem number 3. Okay, and it reads, if a pull of 210 newtons accelerates a 40 kilogram child on ice skates at a rate of 5 meters per second squared, what is the coefficient of friction between the skates and the ice? Okay, so we want the coefficient of friction. That's a force problem. That's a force analysis. So, what is our object? Well, the child is on ice skates. He's the one experiencing the friction. The child is our object. Now let's draw our picture. There he is, and he's being pulled along by a rope. I'm just going to say there's a rope pulling him with that force. Okay, now we want to look at our interactions. So we'll develop our free body diagram. At the same time, we look at those interactions. So start thinking about your interactions. One interaction is going to be our force of gravity. And that's between our child and, of course, the earth. So how does the force of gravity look on our free body diagram? Well, no points down. Fg, mg, equal to the weight, keeping all those ideas together. Okay? What's another force? Well, the child's interacting with the ground, and so we have a normal force between the child and the ground. The ground is getting pushed down by the child, so it's pushing back up on the child, and we have a normal force. If I think about all my forces up and down, that's it. Those are the only interactions. And so since he's not changing his motion up or down, those two forces should look the same. That's sort of my prediction at this point. Okay, well, what other forces are interacting? Well, he's getting pulled, so we have the force of the rope, and that's between the child and the rope. And as I've drawn it, we'll say the force of the rope is to the right. Last thing, well, it says it's looking for the coefficient of friction, so even though it's ice, because it's asking about friction, we can consider friction. Now, we always have to ask ourselves, is it kinetic friction or static friction? Well, he's accelerating, so he's moving, so he's sliding. That is kinetic friction. So the coefficient we're looking for in this problem is in fact the kinetic coefficient of friction. Friction opposes the motion, so we're going to put friction in the opposite direction that we know the skater is heading. Now, why would I have drawn that arrow a little smaller? Well, my prediction right now, those are the only forces acting, and so perhaps since he's accelerating, I need to be thinking about the forces to the right being bigger. So they're bigger, and friction is smaller to the left. Okay, so I'm interested in that frictional force, specifically its coefficient. So I'm going to continue my analysis, looking at all the forces, listing them, and then exploring their horizontal and vertical components. Again, because the motion is separate, and he's only moving in the horizontal direction, so maybe I only need to worry about horizontal forces. All right, so my first force, well, that's the force of gravity. Nothing horizontal, only in the vertical direction, and it's down, so I have that negative. Force 2 is the force of the rope. It's to the right, nothing vertically. Positive gives me to the right. Force 3 is my normal force, nothing horizontal. It is up, so that's a positive vertical. And force 4 is my frictional force. It acts horizontally. It's, of course, to the left, so we make it negative. Time to apply Newton's second law. Sum of the forces in either direction are equal to the acceleration in that direction. So horizontally, those forces are equal to the mass times the acceleration horizontally. And vertically, those forces are equal to the mass times the acceleration vertically. Let's sum them up. Horizontally, we have the force of the rope. It's positive, plus a negative kinetic friction, and that's going to equal mass times the acceleration horizontally. Now, friction is what I want, the coefficient specifically. So we're going to break up what frictional force actually is. And we have the force of the rope, which we know to be 210 newtons, minus, there's my minus. Now, friction is equal to its coefficient times the normal force. We have a mass of 40 kilograms, and we're told that he's accelerating at 5 meters per second squared. So I have 210 minus the coefficient, I don't know the normal force, equals 200. I need that normal force. Well, the normal force is related to the vertical forces. It's one of the vertical forces. So let's look at its analysis in terms of Newton's second law. So we have minus, we're going to sum these up, minus Fg plus the normal force equals the mass times the acceleration vertically. The object isn't changing its motion up and down. So that acceleration is 0, therefore the sum of the forces must be 0. And we find that the normal force equals the force of gravity, which equals mg, which equals the mass of 40 times 9.8. So our normal force is equal to 392 newtons. Now I can take that, add it in over here, and we have our relationship 210 minus mu sub k times 392 is equal to 200. So now I just have to solve for my kinetic friction. And we find that the kinetic friction is equal to 0.03. All right, so this is a force analysis problem asking specifically about a force, the frictional force, and what its components are, coefficient of kinetic friction. So we identify our object, look at all those interactions, separate the motion into horizontal and vertical, and therefore the forces are separated into horizontal and vertical. Examine the horizontal motion because he's accelerating horizontally, friction's acting horizontally, and that's what we're interested in. Realizing that we need that normal force. The normal force is a vertical force, so we look at that vertical analysis, and then we can plug it in. Good job.